everyone. This is a lesson on acids and bases and their properties. So by the end of this lesson, you should be able to summarize the characteristics and interactions of acids and bases. So first, let's start with acids. So these are defined as a compound that produces a hydronium ion, an H3O plus, when dissolved in water. It could also just form a hydrogen, which would be an H plus. So you could see either one of those. Acids go through ionization when dissolved in water, which we learned in our lesson about solubility. So you can go back and check that if you need to. And then some general properties of acids that we look at to know if we're looking at an acid or not is that they taste sour for the ones you can eat. Don't just think you can eat any acid, but think citric acid. So lemons, they're sour. Vinegar is sour. That's acetic acid. They react with some metals in single replacement reactions, so you can go back and look at your types of reactions for that. They are electrolytes, so they conduct electricity, and they can produce painful burns and damage tissue, so we try not to expose ourselves to acids. Many of these are poisonous, so don't drink them or sniff them. And they react with indicators to produce a color change. Depending on which indicator you're looking at, will tell you the color. Come on. I don't know why this isn't doing anything. There we go. Here is a list of common strong and weak acids. So you will want to pause the video and put these in your notes. So go ahead and do that really quick. Oh, let me clear this off. All right, so now let's move on to bases. And bases are compounds that produce hydroxide ions when dissolved in water. Both of these should be on your reference packet as well, hydronium and hydroxide on your polyatomics chart. So check there if you want to review that. Bases go through a process called dissociation when dissolved in water. So this is also on your notes on solubility, so you can go back and review those. And some general properties of bases are that they feel slippery, so kind of soapy. Lots of soaps are very mild bases. They taste very bitter, and they also can have a gritty texture. So think like Tums. When your stomach's upset, you chew up those nasty Tums. That's what that is. Strong bases are very corrosive, so they will break down metals, woods, and tissue. They are electrolytes when dissolved in solution. And they do react with indicators to produce a different color change than acids do. Again, it's all dependent on which indicator you're using at the time. These are used to break down fats and oils, so a lot of your cleaning supplies are basic. Ammonia that some people will like mop with, that's basic. Oven cleaner is basic, things like that. Again, soaps. And here's a list of strong and weak bases. Please make sure to pause the video and copy these in your notes as well. Now that we know about both acids and bases, we can talk about what happens when you mix them together. So, if you mix an acid with a base, you will have a neutralization reaction occur because they neutralize each other. During this, the negative ions of the acid will combine with the positive ions from the base to produce a salt. So that's an ionic compound. And then the other ions, so the positive from the acid and the negative from the base, will combine to form water. So the products of a neutralization reaction are salt and water. And here, this is really important for you to see. Please make sure that this is in your notes, because this is your generic formula. Also, just as a review here as well, neutralization is considered a double replacement reaction, if you want to go back and look at those in your notes as well. So an example of an acid-base reaction or a neutralization reaction is hydrochloric acid with sodium hydroxide. Together they will form salt, NaCl, and a base. So look, we put the inners together, which is what gives us our salt. salt. Come on, computer. Sorry, this is sloppy. And then we put our outers together, which is HOH, otherwise written as H2O. So that's our water there. If you spill an acid in the lab, you will neutralize it with a base, not just any base. Come and ask me, I'll tell you which one you need to use, and vice versa. So if you spill a base, you'll neutralize it with an acid. And this just kind of shows you what happens when you mix them together. So NaOH, you spill that, you neutralize it with NaCl, and you come out with H2O, and I'm sorry, with HCl.